Welcome back. So we're going to continue with part 2 of metal cutting form. As we look into the tool failure modes, let's identify the most important properties of the tool material that it has should be possessed. Okay, so among the properties that the tool material must have will be toughness, so that it can avoid fracture failure. Hot hardness, so that it can retain hardness at high temperature, so that it can avoid the temperature wear. And then wear resistant, where the hardness is the most important properties to resist the abrasive wear. So here are some major tool materials that available in the industry and mostly and widely used. Okay, so there are high speed steel or HSS, plain carbon and low alloy steel, cast cobalt alloy, cemented carbide, ceramic, synthetic diamond, and cubic boron nitride or CBN. Okay, so there are a lot more cutting tools available, but these seven are the most common one used in the industry. So here is the graph showing the typical hot hardness relationship for the tool material. So in this one, um, ceramic has the highest hot hardness compared to the other materials, and plain carbon steel is the lowest one. So cemented carbide and ceramic are slightly significantly harder at elevated temperature. Okay, so that's why ceramic and cemented carbide is really used widely in the industry. So now let's see the typical value for N and C for the high-speed steel, cemented carbide, and also ceramic. If you can see here, the value for N and C for high-speed steel is lower in comparison to the cemented carbide and also ceramic. So ceramic showing the highest one, which the N value is 0.6 and C is 3000 compared to the other type of material. Now let's go to the high speed steel first. So high speed steel is a highly alloyed tool steel, so it capable to maintain the hardness at elevated temperature better than the high carbon and low alloy steel. So since the plain carbon is the lowest one, right? So high speed steel is a little bit better than that one. So especially suit for application for complicated tool shape, for example the drill, tab, milling cutter, broaches. So there are two types of HSS. One is tungsten type, uh, which designated T grade, and molybdenum type designated for M grade. So this is the meaning the tungsten is the additive added into the metal so that it can make the tool better. And another type is molybdenum is included into the HSS material so that it can improve the properties also. So here are some example of the tool created using the HSS. So here is the solid tool for the turning. Okay, so we have also the HSS for drilling. Okay, so there are multiple type of cutting tool, for example for sewing, and then for drilling here, center drill. Okay, and there are a lot more using the HSS. The next one is cemented carbide. So cemented carbide, a class of hard tool material based on the tungsten carbide. So it is using powder metallurgy technique where cobalt is used as a binder. So two basic type are non-steel cutting grade only with tungsten carbide with cobalt, and another one is steel cutting grade is added with additive such as titanium carbide or tantalum carbide added to the tungsten carbide and cobalt. So here are some example of the cutting insert of the tungsten carbide. Okay, so this one is non-steel, what we call non-steel grade, where only tungsten carbide and also cobalt is used in the work material for the insert. And then this one is for the steel grade, where they use TIC or TAC as the additive, okay, added into the tungsten carbide and also cobalt, and then it compressed into insert like this one. And then usually the cutting insert will be placed on the tool holder like this one. For example, this one is for milling, okay, and then before we can use for the machining process. Here are some general properties of the cemented carbide. High compressive strength but low to moderate tensile strength, high hardness, good hot hardness, good wear resistance, high thermal conductivity, high elastic modulus, toughness lower than high speed steel. So cemented carbide is the most widely used cutting tool in the industry due to the reasonable properties, and so because if you can see previously, the properties is in the middle for the hot hardness compared to the ceramic and also the HSS and also plain carbon. But in terms of the price also, cemented carbide is very um, uh, affordable if we can compare, because if you want to see that one cemented carbide compared to the one ceramic, ceramic might be 2 to 3 times higher in terms of the price compared to the cemented carbide. So for steel cutting carbide grade, it is used for low carbon stainless steel and other alloy steel. So in this cutting tool, titanium carbide and then also tantalum carbide are substitute for some of the tungsten. So composition increase crater wear resistance for steel cutting but adversely affect flank wear resistance for non-steel cutting application. So it is good because it increased the crater wear resistance, but in terms of the flank wear resistance, it is not so good for non-steel cutting application. So next is synthetic diamond or sintered polycrystalline diamond or SPD. So it is a fabricated by sintering very fine grained diamond crystal under high temperature and pressure into desired shape with the little or no binder at all. So usually it is applied as coating instead of a solid cutting tool itself, because due to the price, because it's going to be very expensive. So usually it's used as a coating like 0.5 mm thickness to the cemented carbide cutting tool. So this one is the application is for high speed machining of non-ferrous metal and abrasive non-metal such as fiberglass, reinforced polymer, graphite and wood. So this one is not used for steel cutting. So here are the example of the synthetic diamond tool. Okay, so if you can look into this one, only the tips of the tool is used with the diamond. Okay, so it become an insert on the this area only for the cutting process because of the high price. So it made into something small, but it still can perform the machining process. So this one also, the insert is create into a small insert here. Okay, so the same like this one also, it can also brace on the area here on the tip of the cutting tool for the insert. Okay, so for example, the whole thing is cemented carbide, and then they brace the diamond on the tip here for the machining process. Next to the diamond is cubic boron nitride CBN, which is the hardest material known for the cutting tool. So this one fabrication into cutting tool insert as same as the SPD. So usually it is used as the coating of the tungsten carbide insert. So application is for machining steel and nickel based alloy, which is a very hard, super hard material. Um, so SPD and CBN tool are very expensive, so that's why it's used only for certain operation that require a very hard cutting tool. So here let us look into the example of the cutting tool. So if we look into here, same like the synthetic diamond. Okay, so for this CBN also, it is only based on the tips of the cutting tool here, like this one. It is coated on this area for the cutting tool also. Okay, so for the, this is for the what we call for the end milling. Okay, so can be very small here. Okay, this is due to the price which is very high. Okay, so this this material also can be used for the honing tool. Okay, so this is the honing tool, so it is only covered on the outer area here. Okay, so for the honing process. So as previously, we already see the operation where we have single point tool and also multiple cutting edge tool. So now we will going to see the tool geometry for this type of operation. So here is the single point tool geometry. So there are 7 components that you have to know, 7 elements that you have to know on the single point tool geometry. So if we look into the tool, so if we look from the top, you will be able to see the side edge angle, side cutting edge angle. There is nose radius. Okay, so the radius of the cutting tool, and then there are also end cutting edge angle. Okay, so now if we look it into this area, okay, from this direction, you're going to see the side rake angle over here. So, and then we also have the side relief angle, and then if we look it from this area, so from this direction, you're going to look at back rake angle. Okay, so on top here, and also end relief angle. So now let us see the type of holding and presenting a single point tool. So the first one, A, is solid tool, where the whole thing is the same material. So this one is usually tool made of HSS. So B is brace insert. So there are certain insert that brace to the material here. Okay, so then this one is not movable. Okay, so what you have to do is just take, if you want to replace this one, you have to take it out and then replace and brace it again to the tool shank. So another one is the mechanically clamp insert, which is most commonly used. So this one, you can clamp the tool to the tool holder, and then you can easily open the screw here and then replace the insert while performing the machining process. Let us look into the example for the actual tool. So the first one is a solid tool, so you look like this one, and then we have brace insert. So there are brace on the area here. Okay, and the last one is the mechanically clamp insert. So if you can see, this is the insert. It is clamped on the tool holder like this one, so that you can what we can save some money for the expensive tool. Okay, we only use the tips on area here for the cutting. Now let us look into the cutting fluid. So what is cutting fluid? In machining process, if we use any liquid or gas to directly in the machining operation, it is used to improve the cutting performance. Okay, so two main problems addressed by the cutting fluid will be the heat generation at shear and friction zone, and also friction at tool chip and tool work interface. So in this area, cutting fluid is used to reduce the heat generation during the process of machining. For example, like this one. Okay, so if we use the liquid into this area, so the temperature will start to reduce, and then we can prolong the tool life, and then it can also reduce the friction in between the cutting tool chip and also the work materials. For example, like this one, it is oil based. Okay, so it make it into what we call it, reduce the friction between the tool and also the work material, so that the work surface will become smoother, and the tool also can be used for a longer time. Other function and benefit of cutting fluid will be, for example, it can also help in washing away the chips in the grinding, in milling, in drilling, and also the turning process. So it can reduce the temperature of the work part for easier handling, because when you know that the chip is very hot, okay, so when it goes out from the machining area, it can cause what we call it can goes to the worker that work on the turning process or the milling process, right? So it is very hazardous to the operator. So it can reduce that temperature. It can reduce also the temperature of the workpiece, so that we can easily take it out after the machining process. So it can also improve dimensional stability of the work part. So cutting fluid can be classified into two. One is coolant and one is lubricant. So coolant designed to reduce effect of heat in the machining, and lubricant is designed to reduce tool chip and tool work friction. So this picture is showing how the friction between the cutting tool and also the workpiece will look like. So during the machining, you will see that there are like a spark of fire, spark during the machining process. So that's due to the friction between the cutting tool and also the workpiece. So for coolant, it is water is used as the base for the coolant type cutting fluid. So it is most effective for high cutting speed, where heat generation and high temperature are the problem during the operation. So most effective on tool material that are most susceptible to temperature failure. For example, the HSS. So for the lubricant, it is usually oil-based fluid and most effective at lower cutting speed, and also it reduces temperature in the operation. Despite the goodness that bring by the coolant and also the lubricant, there are also some problem with it, what we call as cutting fluid contamination. So during the operation, there are a lot of things might happen, so that it will contaminate the cutting fluid. For example, there might be tram oil or machine oil or hydraulic oil that mix up together with the cutting fluid during the operation. So it can also be garbage, for example, cigarette butt, food, or etc. that mix together during operation. And sometimes small chip also might mix together with the cooling material, with the cutting fluid. And finally is mold, fungi, and bacteria can also accumulate inside the cutting fluid. This is because cutting fluid usually is reused again and again in a operation. So that's why this might happen. So if you don't use the machine for a long time, then mold, fungi, and bacteria might be accumulated inside the oil. In order to deal with the contamination, so what you have to do is you have to replace the cutting fluid at regular and frequent interval. So if let's say you are not using the machine for a long time, so you might want to check the cutting fluid. So if it is a lot of fungi and a lot of garbage inside there, you might want to replace the whole thing. And then you might also want to use filtration system to continuously or periodically clean the fluid. And another method, you might want to use dry machining, which is not using the cutting fluid during the operation. So what is dry machining? Dry machining is no cutting fluid is used during the operation, so that you can avoid problem of cutting fluid contamination, disposal, and filtration problem. So problem with dry machining is, of course, because we use the cutting fluid in order to cool down the operation, right? So if you don't use any cutting fluid, then overheating of the tool might happen, and then operating at lower cutting speed and production rate to prolong the tool life is might be needed. And then They'll be absent of chip removal benefit if there is no cutting fluid, so then the chip will not easily wash away. So that's the end of the class and also the end of metal cutting topic. So see you in the next class. Thank you for listening. Assalamualaikum.